You probably clicked on the video wondering what the hell is that thumbnail? This is especially true if you don't know anything about integration by parts. Well, you're in luck. In this video, I will talk about it, and hopefully by the end of it, you'll be able to attain a conceptual understanding of what integration by parts entails. And as a result, you understand the meme. So, to get started, let me first introduce the the most, I guess, popular formula of integration by parts. All right. I say popular because this is the most, if you were to search up integration by parts, the first thing that comes up will probably be something on the lines of this. It's certainly compact, but I wouldn't say this is the most effective way to learn it. I've been taught that it doesn't, let me rephrase. It certainly doesn't tell you when you should use integration by parts. So a better form would probably be this. Now this is obviously much longer, but don't be fooled. They're basically the same thing, where u is f of x, and dv is g prime times dx. Now you can see when you should use integration by parts. Now it's when you have a product of two functions, f of x and g prime of x. So yeah, one of the functions is going to be a derivative. So you have to make sure you'll be able to also integrate g prime of x as well. For the rest of the video, I will just use the first formula, this one, instead of the second one, because most people are probably more acquainted to UDV and UNVs rather than this long form. But I encourage you to write this one out as well, or jot it in your notes, because this gives you a stronger conceptual foundation, whereas this one just very easy and efficient for computation. So let's start with an example. Let's do an easy one. Now, if I were to give you this problem in whilst you were still in Calculus 1, you would try, but to no avail, to solve this equation. Yeah, this is impossible, at least to my knowledge. You can't to solve using U substitution. It is you if you want to set u equals x, you will have to deal with this. You can't deal with the sine x, and vice versa. But as we can see, this is a product of the integrand is a product of two functions similar to what we have up here. So we can label these functions as this, such that u is equal to x and dv is equal to sine of x dx. All right. So we also need to find v as well as du. Du is very easy. Du is simply just 1. And v, if you know your identities, it's just negative cosine of x. All right, now let's assemble this. We know, so uv, so let's see, negative cosine x, so negative x cosine x minus, let's see, v, let's see, so v is negative cosine x. Oh, there should be a dx here. Yeah, times du, which is just simply dx in this case. And this is also a very simple integral to solve. This is just negative sine x. So so if you were to solve this thing completely, you'll have negative x cosine x plus sine x plus c. Yeah, don't forget about the c. That's very important. This is not a definite integral. And this would be our answer. Okay. As you can see, we have successfully solved the x sine x dx. Now, don't get it. Now, there is a very important thing you need to know, and that is, even though I set u is equal to x, you can also very well be sine of x as well. The reason I set u is equal to x is because it's more convenient for me to solve. If I were to set u is equal to sine x, things would very quickly become extremely complicated. Let me show you what I mean by this, by switching our functions for u and dv. So give me a minute. All right, we have now set this up. So du is equal to cosine x. And we have v, if you were to take the integral of this, would be just simply x squared over 2. Now, assembling it, we have x squared over 2 times sine x minus the integral of cosine x x squared 2, put dx here, times the differential. Now, I want you to compare this integral with this one. As you can see, this integral, the one we derived, is basically as hard, if not harder, than the original integral we solved. So this setup right here, where u equals sine of x, is a no-go, because we just made our original problem much more difficult to solve. So as you can see, there's a bit of a I wouldn't call it guessing, as But there is a more of a nuanced way of solving these and classifying what is your u and what is your dv. So the typical rule for this is that u should be a simple function. A simple function. Okay, what I mean by this is that the derivative of u, du, should be simplified or less complex when you take the derivative. So a good example would be x squared, right? If you were to take the derivative of this, it'll become 2x. So you go from a quadratic behavior to a linear behavior, which is, I guess, in my opinion, which is much more easier to deal with and easier to integrate later on. Now, if you were to put u as e of x, nothing would change, right? The derivative of e of x would be the same, e of x. So you're not really simplifying it. So let me write this down. This is a simplified version. And a similar case is when u is equal to a trigonometric function like sine of x or cosine of x. Because if you were to take the derivative of sine or cosine, you'll just get, if you take sine, you'll get cosine, then negative sine, then negative cosine, and then back at sine again. So it doesn't really get simplified. It just kind of it's stuck in this, I guess, loop where it's of the same difficulty. So that's why you have to choose. You make your u's and dv's carefully. So all you need to know is that to test it out, you should take the derivative. If you're not certain, take the derivative of x and sine of x, right? Or take the derivative of the functions and see which one has been simplified from the original version. If it's simplified, it's best to use u as that. It's best to use u for the simplified one. If you're not sure, it's good to just guess and check. If you can, such that if you were to set this up and see that the second integral that we derived is more complicated than the first one, it's probably best to take a step back and try the other option. Okay, so yeah, in conclusion, you should use integration by parts if you see a product of two functions like this one, but you can also see another one could be something like this. Sorry, I don't know why there is some flashing going on. So yeah, this you could also use integration by parts to solve this as well. But this one is much more difficult as you can't solve it directly. You would actually need to solve it implicitly by moving around the terms when you get to this final step. You might actually have to integrate this twice, I'm pretty sure. If you want a lesson on that, I can also do it if you leave a comment. But yeah, otherwise, this integration by parts is a very, very powerful, I wouldn't say, I think it's one of the most important tools you'll learn in Calculus 2. And hopefully you'll be able to understand the meme now.